Number 9. Baseball is thrown from point S in right field to home plate. The dashed line in the diagram shows the path of the ball. For this exercise, use a coordinate system with up as the positive vertical direction and to the right as the positive horizontal direction, with the origin being at the point the ball was thrown from, which is point S. So the most common error in this problem is setting it up, and it gives you exactly your directions here. It's not more complicated than that. So as this ball is traveling through the air, we know a couple things about its motion. So one of the things that we know is that as it travels along this path, it will be traveling with a velocity that is changing because it's changing direction. Each point along this path, we have a vertical component to our velocity, and you can notice that that vertical component not only changes in magnitude but in direction. It's positive in the beginning and then it becomes negative after reaching the top, at which point it is 0. And then we also have this horizontal component to our velocity. The horizontal component to our velocity is the same at every given point in time. So when we go below to draw the horizontal velocity and the vertical velocity, what we're going to see is that in the horizontal direction, our velocity is a constant negative value. Why is it negative? Because our coordinate system said that to the right is positive, which means that each of these is in the negative direction. My velocity in the vertical direction is going to be something that's changing. It starts as a positive value at point S, the origin. It decreases and then reaches 0 at the apex of that trajectory, and then becomes negative. You can think about it. You already know why that happens. Gravity's pulling on that thing. So your vertical velocity versus time graph should look like that. Now when we think about acceleration, if we need to figure out what our horizontal acceleration is and our vertical acceleration, you already know a couple things here. Gravity is what's causing that vertical acceleration. There we go, with not a highlighter. And in the horizontal direction, we have no acceleration. So there we go. A horizontal acceleration versus time graph where 0 is the value at any point in time. In the vertical direction, we start with a positive velocity, but it is constantly decreasing. So we have a negative change in velocity. That negative change in velocity is equal to the acceleration of gravity. So we have a negative constant acceleration. All right, number 10. We've got 2 toy trucks. They're rolling off the ends of tables. So this should be a question you don't even have to think about answering here. You know that what determines the amount of time that an object is in the air has to do with the height it is above the ground. That is because gravity will be accelerating that object towards the ground. There is no acceleration in the x direction. Therefore, only the height determines how much time that object has in the air. So, will truck A, which is at a lower height, be in the air for longer, shorter, or the same? Well, shorter height means shorter time. So your explanation can include things about ignoring all of these other horizontal components. Those might determine how far it goes laterally across the ground. But in terms of what's happening, you know that the displacement of an object is related to its initial velocity times time plus 1/2 times its acceleration times time squared. With an initial velocity in the y direction of 0, the only thing that determines how much time that object is in the air is how high it is off the ground. If this is a bigger number, this is a bigger number. There's more than one way to explain or answer this question, so you don't have to show a mathematical answer. You could explain thinking about how gravity works and the fact that it causes a constant acceleration and that's what is changing the position of this object, because it has an initial in the y direction of 0. So there's more than one way to explain this. Okay, let's take a look at number 11. Ball is thrown straight upward and falls back to the same height. Student makes a graph of the velocity as a function in time. What, if anything, is wrong with this student's graph? Let's start by saying that first, yes, something is wrong, and we need to explain that error. So here's a person, and let's say what they do. They're throwing a ball straight upwards. We can call up the positive direction if you want. So they're throwing their ball straight upwards. The velocity of the ball appears to be decreasing over time. So the velocity of the ball in the vertical direction is getting slower. So, wait, why did I put a little thing over there? Boop, boop, sorry about that. So their ball over time is getting slower until the velocity reaches 0, right? Then this graph shows that the velocity begins to increase again in the positive direction. So this ball reaches a point where its velocity is 0 and then begins to speed vertically upward, possibly off the surface of our planet. If that's how things move when you throw them up in the air, well then I would really like to see that. So please demonstrate that next time you are in class. This graph, what it should show, if this was a real life ball, is that the ball goes upward in the air with a velocity that begins to decrease until it reaches 0, and then has a negative velocity and accelerates downward. So at this point, it should continue with the same slope. Why? Because the slope of a velocity versus time graph is acceleration, and you know that the acceleration due to gravity is constant for objects on planet Earth in our gravitational field, regardless of mass. So you can explain that. If you can't, go back and study your notes. Okay, now for the fun times. Wonder Woman, flying in her invisible plane at a constant 215 kilometers per hour horizontally, spies Ares in disguise as a gentleman going for a country drive. He's cruising along at a constant 155 kilometers per hour along a level highway when she decides to leap and land in his car just a mere 78 meters below. At what angle to the horizontal should the car be in her sights when she decides to jump? So we're looking for an angle, but we have this complex motion problem to solve first. Okay? The first thing I'm going to do to solve this problem is determine the relative velocity. That's so that I don't have two moving objects that I've got to consider. I can think of these from the perspective of one of the objects and then analyze it from there. I'm going to think about it from the perspective of Ares, because that means he's going slower. So then that way he's essentially at rest. What I'm doing is determining how fast is Wonder Woman moving relative to his velocity. So if I want to find what the relative velocity is, I'm going to take Wonder Woman's velocity minus Ares' velocity. I'm going to determine that, well, 215 kilometers per hour minus 155 kilometers per hour is in fact 60 kilometers per hour. I'm going to write with a smaller pen on here because that's pretty hard to see. Because I'm an annoying person, I obviously gave you a number that is not in meters per second, and we know that we need to turn this into meters per second because we have an acceleration due to gravity that's going to contribute to this problem that is in meters per second squared. So if I want to take 60 kilometers per hour, I'm going to set up my dimensional analysis. In 1 hour, there are 60 minutes. In 1 minute, there are 60 seconds. In 1 kilometer, there are 1,000 meters, and I'll plug that in my calculator and get 16.67 meters per second. So that's the first step of my problem. I guess you could call this a step 2 if you want, making sure my things are in the units that are going to be useful to me. Now I have a really basic freefall problem. This is now just a projectile that's moving and is going to hit the stationary ground. So I'm going to think about it like a freefall problem. I know that when I'm solving a freefall problem, I'm going to analyze the y direction first, because that's where gravity is causing changes in motion. Everything else is constant in the x direction. So I'm going to start by thinking about what's happening in my y direction. So a couple things I know. The displacement in the y direction is 78 meters. The initial velocity in the y direction is 0 meters per second. The acceleration is the acceleration of gravity. I'm going to treat it as positive in this case. We have nothing moving up, so I'm just going to use all positive values here. Meters per second squared. And what do I almost always want to find? I want to find the time it takes for that object to fall. And my final velocity is left out. That is irrelevant to me solving my problem. I'm going to choose the kinematics equation that has no final velocity in it. I'm going to eliminate this term because my initial velocity is 0. And I'm going to put a little g in there. So delta y is 1/2 gt squared. And I want to solve for t. So when I do my algebra, that looks like this. If you're not sure how I got that, pause the video and work out this algebra right here. If you're not sure where this came from, pause and do that. Okay, so now let's plug in our values. My time is going to be equal to 2 times 78 meters. That's an 8. Divided by my acceleration of gravity. And then I'm going to plug that in my calculator. And I get that our time is 3.99 seconds. To make things easy for myself, I'm actually going to call that 4 seconds. That should give you an idea about your rounding accuracy and ways that you could have a slightly different number than me at the end and everything is okay. So now, the next step of my problem, I'm going to solve for what's happening in the x direction. Because I reduced this to a relative velocity, now I know that I can find what that displacement is. Because if you think about what the question's actually asking, they're asking you to figure out something about the physical space here. This angle that we're looking for is about where in space Wonder Woman should be looking if she wants to line herself up with Ares' car. So I know one side of a spatial triangle here, the 78 meters. So I want to figure out what's this other side of the triangle. That's going to determine for me what that angle is. So now we're going to figure out what's happening in our x direction. I'll leave my y direction information up there. So I know that in the x direction, we've got no acceleration, which means that my initial velocity and my final velocity in the x direction are the same. And I figured out what those were, for what that was for Wonder Woman. She's moving 16.67 meters per second relative to Ares. I know that the time that she makes that motion is 4 seconds long. So now all I need to do is figure out what's her displacement. Because she has no acceleration, she has a constant velocity, which means that I'm just going to use my basic definition of velocity, that it's displacement over time, in order to solve for that displacement. So Wonder Woman's displacement is equal to her velocity times time, which is 16.67 meters per second times 4 seconds. When I plug that in my calculator, I get 66.68 meters. You might have a slightly different number depending on how you rounded. Remember, that's not really what's important there. So now I know that when she jumps is when she should be 66.68 meters away from Aries. It's a great example of why you have to be able to justify things with math. You'll notice that what this triangle looks like does not match what the numbers say, so that you cannot just assume that the diagram is something that tells you what you should find. You have to use your brain and use your math to back up what you're doing. So now we've got the sides of two triangles. So our final step in this problem is we want to solve for theta. I've got a triangle with a 78 meters on one side, 66.68 meters on this side. It's a right triangle because x and y are perpendicular to one another. And I want to find angle theta. So the tangent compares my opposite and my adjacent side. So I'm going to choose that. Since I don't know the hypotenuse, why bother to find it? So the opposite side of my triangle is 78 meters divided by 66.68 meters. So in my calculator, put in what the inverse tangent is of those numbers there. 66.8. And that is going to tell 49.47 degrees. For Wonder Woman. Problem 13 is the one that we already worked through in class earlier this unit. A military airplane is flying 1,200 meters above the ground at a speed of 200 meters per second. We can assume that's horizontal, especially based on the diagram. It drops a practice bomb, not a real bomb, that hits the ground after traveling a horizontal distance of 3,130 meters. So, this horizontal distance right here is 3,130 meters. Ignore air resistance. So we want to decide for each of the scenarios below, will that distance be greater, less than, equal to, 0, or something that we cannot determine. So in thinking about how to answer this problem, before I read any of them, I know that what determines how far something goes, if I think about how we solve this problem to determine horizontal distance traveled, has to do with how high above the ground that object is, because that's what determines the time it is in the air. That in the x direction, we have a constant velocity. So that horizontal distance is directly related to the time that the object is able to fall. The two things that determine that horizontal distance are going to be this falling distance, because that will change the time. A greater distance means a greater time. The other thing that can change the horizontal distance is this horizontal velocity. If that horizontal velocity is greater and time is the same, an object moving faster in the same amount of time will go farther. So, without further ado, let's think about each of our problems here. So, for number 1, if the plane's speed is tripled, well, that's what I was just talking about. Greater horizontal velocity means greater horizontal distance. Be sure to explain. If the plane is climbing straight upwards, well, then our horizontal velocity is 0 if it's going straight upwards. Then if there's no horizontal velocity, then there's no horizontal displacement, which means that the horizontal distance will be 0. If the plane is flying in a level flight at an altitude of, we've got a lower altitude, 1,100 meters instead of 1,200. Well, I know that less height means less time. Less time means constant velocity. less distance. So this is another one that's going to, or this one is going to be less than what the test distance was. All right, number 4, the mass of the bomb is increased. You already know not a single one of your equations includes the idea of mass, so who cares? The horizontal distance is going to be c, the same. The bomb is thrown from the plane with a vertical velocity downward. Well, what's happening in the y direction is that this object is accelerating. Here we have the same height, we're assuming, but we have a greater velocity. Something moving faster in the same amount of time can go a greater distance in that same amount of time. So now that object is going to travel that 1,200 meters to the ground in less time. So this object, because there's less time, means in the horizontal direction, it will not have as much time to go. So this is going to be b, less than. 6, the plane is diving at an angle of 20 degrees at a height of 2,000 meters. So for this one, you actually have a little bit of math to do, don't you? So let's actually solve this problem here, just so you can see where our numbers are coming from. So first thing that I want to do is I want to figure out how much time that object is in free fall. So like a free fall problem, I'm going to start by analyzing my y direction. So we've got an initial velocity that is something other than 0. The plane is traveling 200 meters per second. Apologies, let's just zoom over here. The plane is traveling 200 meters per second at that angle of 20 degrees. So if I want to know what the vertical component of my velocity is, then I need to find, that's the opposite side. My vertical component is going to be my velocity times the sine of my angle, which is going to be 200 meters per second times the sine of 20. If I plug that in my calculator, I get 68.4 meters per second. So if I was flying at the same altitude, I know that I would be falling for less time because I was starting with an initial velocity that was not 0, which would mean that then I have less time in the air, which means my horizontal distance would be less. But I also know that I've got a horizontal velocity that's going to contribute here, and I've got this greater altitude. So let's figure out how much time it will take for our object to fall. I know that my acceleration in the y direction is going to be the acceleration of gravity. I know that my vertical displacement is 2,000 meters. So I'm going to even reuse my equation from a previous problem. And if you don't know where I got that, you should go back and figure it out. The time to fall is going to be equal to 2 times my displacement times the acceleration of gravity, or divided by the acceleration of gravity. And then I'm going to take the square root of that. If I put that in my calculator, I get 20.2 seconds. So now let's think about our x direction. We now know how much time that practice bomb is going to be in the air. So in the x direction, we need to figure out what our horizontal velocity is, because it's not going to be the 200 meters per second that it has been on all the other problems. Our velocity in the x direction, if I go back up and I think about my triangle over here, it's going to be my velocity times the cosine of my angle, 200 meters per second. If you're not sure where I got those numbers, that's a good thing to review. Khan Academy would be an excellent place to go to figure that out. So if I plug that in my calculator, I get 187.9 meters per second. So this object in the x direction has no acceleration. So that means my velocity is constant. So if I want to know how far something is going to go, all I need to do is use my basic definition of velocity to figure it out. So my displacement is going to be equal to 187.9 meters per second times 20.2 seconds that I found up here in my previous problem. All right, when I plug that into my calculator, I get 3,795.58 meters. So that may seem like a lot of work, but same type of problem we've been doing all this time. When I go back and I look at my situation right here, that is greater than the distance of the practice bomb, which is option A, greater than. All right, number 7, the easy one here. The plane speed decreases, but it's flying at an altitude of 1,800 meters. Because it doesn't tell us how much it decreases, it's impossible for us to know. And the last problem here, when we look at Charlie and Brandon arguing about who can hit a golf ball the farthest, enjoying the brisk fall weather, they begin to swing away, sending golf balls flying, some short, some far, some high, some low. Kaylin watches and says, who can hit a ball the highest? So, design an experiment to determine the maximum height attained by a flying golf ball. Ignoring air resistance and weather, which is miraculous, of course, assume you have access to the equipment found in a standard school physics laboratory. Things that you need to think about as you solve this problem. What are you going to measure? What equipment are you going to need to choose to use, and how do you use it, especially if you choose a creative way to use it? And then describe the procedure used to answer Kaylin's question. Imagine that you give enough detail so someone could replicate your experiment. The second part of this problem, it asks you, how would you represent this data using a data table? So when you think about your results, what are you going to put together and show how that allows you to answer Kaylin's question? So we haven't done a test item like this, but you have definitely answered this kind of problem, both in a story problem in your practice, and you've also designed plenty of other labs as we've gone through the year. You've done things, so you've seen labs in action, and you've also designed a few yourself. So small ones maybe, but ones you can logically think through. We want to figure out what this height is. Now, if that ball is up in the air, if we're using the standard equipment in a science classroom, we don't have a tool that's going to allow us to just find that object up there. Instead, we're going to have things like meter sticks or measuring tapes. We're going to have timers. We're going to have protractors. We're going to have string. I'm putting string on there because that's my idea. And, some of you might have had that same idea as well. We're going to need to essentially take our knowledge of freefall. So that's the physics knowledge that I'm looking for in this problem. And AP, when they grade a problem like this, they create a rubric. They're not like looking for every single bullet point. Instead, they've created a way to look at your thinking to determine, do you understand the physics and can you be a good scientist about this? So these are the sorts of things that I look for when I read your answer to this one. 1, do you understand that we can relate the height an object goes in projectile motion to the range of that object? Now, I don't mean that you have to use the range equation that, I told you was stupid. If you memorize that or you want to derive it or that makes sense to you, you absolutely could use that to solve this problem. But I mean, can you go up here and think about this horizontal distance and realize that that horizontal distance is related to the vertical distance. And the other thing that you need to know is that if you want to find and relate those two things, it has to be if you know the angle. So we can relate those spatial variables there if we know the angle relating them. Now, there's a couple other things that you might need to find. For example, it's not just enough to say that if I know my horizontal displacement, I automatically know my vertical displacement, because we have acceleration that's different in these two different dimensions, right? In the vertical direction, I have an acceleration that's equal to gravity, and in the x direction, I have no acceleration. So the motion up and down will be different than the motion left and right. So if I want to actually figure out how high that object is going, the other thing that a rubric scoring your writing will look for is you need to figure out some way to determine the initial velocity of your object. Now, this is a great example of your creativity in action here. Do you think that that was an easy thing to measure if you're swinging with a golf club? Probably not with the average physics equipment that's in here. And so this is where your creative thinking about how to solve this problem comes in. Could you say, let's use the slow motion cameras on our phone and set up some sort of wall or grid that will allow us to measure or observe displacement and time on the slow motion camera? You absolutely could. Could you say instead that you're going to actually do a billion trials hitting that golf ball so that you can do it incredibly accurately, so that you can figure out a good way to estimate what that velocity of a perfect swing is? You could absolutely do that. Those are two very different methods, but they're also very good. Could you do something else creative? Could you pull in some other physics knowledge and you could figure out something about the impact of that golf club and determine velocity from damage done or from sound or something else? Sure, I have no idea what that is. That sounds like a lot of work to me at this point in our current understanding. So there's more than one way that you could arrive at this answer, but what I would be looking for is, do you know that part of what you need to do is determine that initial velocity of the ball? And then your method, it needs to be something logical and reasonable, and from there, I'll say, yeah, okay, I think I get that. That's also why there's this clause in there about it has to be something that another student or me, that I can read it and go, cool, I think I could do that with stuff that's in my garage. So the two main writing parts of this problem are where you're describing this procedure and then where you're figuring out what kind of data table you'll set up. That might seem like a difficult task to do. Often students struggle with making a data table. And unfortunately, in putting an answer guide in here, I can't really describe one right way to do it because it depends on what method you put in there. So here's the other things that I would look for in this rubric. I'm going to look for, are your steps logical? Ooh, I can spell. I put slept. Oh, that's funny. Steps, they have to be logical and sequential. Nobody wants to read a recipe that says put the cake in the oven and then says mix all the ingredients together. That's going to yield some results that are not quite what the baker intends. So your steps, they need to be logical and sequential. And the idea is, remember, you're explaining something to a science literate, clever grandma. Somebody who's going to go, okay, I got you. but I've never taken a physics class, so you need to be thorough about what I'm measuring and what I'm recording, but I can read and understand what you're saying. Your steps need to include information about what you're going to measure and record. So if you're recording just distance and time because you're doing 1 billion swings and you're going to use those, and that's what you're going to do to determine that velocity, you need to be specific about that. If you're going to be using a slow motion camera and a grid, you need to explain how you're going to set that up. Could you also include a diagram for how to include and set up your equipment? Sure. Both just diagramming and describing how to use your equipment are valid ways to pursue that and communicate that. The final thing is thinking about, like I said, that graph or data table. So that has to show that you know how to collect enough information. It might include the idea of, do you calculate an average, and what do you calculate an average of? Or if you're going to use a graph, how you would analyze that graph to find the information that you might need. So there's sort of these multiple layers that I'm looking for when I score this answer. And it isn't just about checking things off. This is why it takes forever for them to score your AP test, right? It's because I'm really looking for, do you understand projectile motion? Can you figure out that the angle is relevant as well as the initial velocity? And can you figure out a way to measure those things using the tools that you so choose? Then, can you communicate logically and sequentially what to measure and record? And then, can you give me enough information in a data table to show me how you would analyze that data, or how you would collect enough to determine an average that could be used to determine the height of the launched golf ball? So those are the ways that this problem is scored. And that's the thoughts that go through my head when I read your answer, and should go through your head when you're trying to determine, how do I write this in a way that communicates what I really want and mean to say.